Hey there, fellow explorers. Isn't it amazing to learn something new every day? I love it. Today, let's dive into the world of humanoid robots, those incredible machines designed to look and move like us. As software engineers, you're already masters of the digital world. Now, get ready to explore how your skills can bring these human-like machines to life. It's a field brimming with challenges and rewards, and I'm excited to share it with you. What makes humanoid robots so fascinating? For starters, they tap into our natural curiosity about creating artificial beings. Beyond that, they hold the potential to reshape our world, making it safer and more efficient. Are you ready for the adventure? Let's go! Now you might be wondering, why build robots that look like us? Well, it's all about making them work seamlessly in our world. Think about it. Our buildings, tools, and environments are designed for humans. Humanoid robots, with their 2 arms, 2 legs, and a head, can easily navigate these spaces. They can climb stairs, open doors, and use human tools without needing a complete redesign. That's pretty neat, right? But it's not just about fitting in. Humanoid robots are also being designed to take on jobs that are dangerous or repetitive for humans. Think working in disaster zones, exploring hazardous environments, or even doing those tedious household chores we all try to avoid. Building a humanoid robot is no easy feat. It's a challenge that pushes the boundaries of engineering, design, and creativity. Every step from the initial sketches to the final assembly demands precision and innovation. Imagine putting together a super complex puzzle, but instead of cardboard pieces, you're dealing with advanced materials, intricate sensors, and powerful motors. Each component must fit perfectly, and even the smallest error can cause major setbacks. One of the biggest challenges is creating joints that move smoothly and precisely like ours. Human joints are incredibly flexible and strong, so replicating that in metal and plastic is a huge engineering hurdle. Each joint needs multiple motors and sensors to mimic human movement accurately. These tiny machines must work together seamlessly, responding instantly to commands and feedback. Then there's the issue of balance. Humans make it look easy, but for a robot, it's a constant calculation. Even a small misstep can send it tumbling, so stability is a top priority. Sensors throughout the robot's body provide data about its position, orientation, and movement. Complex algorithms process this information in real time, helping the robot stay upright, even when walking on uneven surfaces or reacting to sudden changes. And don't forget about overheating. All those motors, processors, and electronics generate a lot of heat, especially during intense activity or long periods of operation. Engineers are constantly working on advanced cooling systems to prevent the robot from turning into a hot mess, literally. Without proper cooling, the entire system could shut down or even get damaged. So keeping things cool is just as important as making them move. Now let's talk software. This is the invisible force that truly brings robots to life. While hardware forms the body, it's the software that acts as the mind, orchestrating every movement, every decision, and every interaction. This is where your expertise comes in, my friends. Software engineers are the architects of intelligence, designing the logic that allows robots to do more than just stand still. The hardware is impressive, but without software, a robot is just a fancy statue, an impressive shell with no ability to think, learn, or adapt. Software gives the robot its brains, its personality, and even its ability to learn from experience. It's what allows a robot to go beyond pre-programmed routines and start making decisions on its own. It processes data from all those sensors, cameras, microphones, touch sensors, and translates it into actions. Every sound, image, or touch is analyzed and interpreted by complex algorithms. It's like the robot's nervous system, constantly receiving information and making decisions. Just as our brains interpret signals from our senses, the robot's software must do the same, but often at lightning speed. One of the key challenges is real-time control. The software must process vast amounts of data in milliseconds to ensure the robot reacts appropriately. Just like us, robots need to react quickly to changes in their environment. Whether it's a sudden obstacle or a new command, the software must adapt instantly. Imagine a robot walking down a hallway and suddenly encountering an obstacle. It has to recognize the object, decide what to do, and execute a safe maneuver, all in real time. The software needs to process this information instantly and adjust the robot's course to avoid a collision. This requires sophisticated algorithms and seamless integration between hardware and software. This is where things get really interesting for software engineers. You're not just writing code, you're solving real-world problems and pushing the boundaries of what machines can do. You get to develop the algorithms that allow robots to navigate the world, interact with objects, and even respond to human emotions. The possibilities are endless, and the impact of your work can be truly transformative. Here's where it gets even cooler: artificial intelligence. AI is the secret ingredient that's transforming robots from simple machines into adaptive, intelligent helpers. With AI, robots are no longer limited to following pre-programmed instructions. Instead, they can actually learn, adapt, and even predict what might happen next. AI is revolutionizing robotics, allowing robots to learn from their experiences and improve their performance over time. This means that every time a robot completes a task, it gets a little bit better at it, just like humans do when they practice a skill. Imagine a robot taking its first steps. At first, it might stumble or move awkwardly, but that's all part of the learning process. It might be a little wobbly at first, but with each step, it gathers data about its movements and the environment. Sensors feed information to its AI brain, helping it understand what works and what doesn't. AI algorithms analyze this data and make adjustments to the robot's gait, making it smoother and more efficient. Over time, the robot learns to walk confidently, adapting to new surfaces or unexpected obstacles. AI also helps robots react faster and make better decisions. If something suddenly appears in their path, they can quickly figure out how to avoid it, keeping themselves and the people around them safe. By analyzing vast amounts of data, robots can learn to anticipate human actions and respond accordingly. This makes them more helpful and intuitive in everyday situations. For example, a robot assistant could learn your daily routine and have your coffee ready just as you like it. Over time, it could even suggest new recipes or remind you if you're running low on supplies. And remember that overheating problem? That's another area where AI shines. AI can help there too. By constantly monitoring temperature and system performance, it can take action before things get too hot. By monitoring the robot systems, AI can optimize energy consumption, reducing heat generation and extending the robot's operating time. Pretty cool, huh? With AI, robots are becoming smarter, safer, and more useful than ever before. Now, let's meet some of the stars of the humanoid robot world. One of the most advanced robots out there is Atlas, developed by Boston Dynamics. Atlas is known for its incredible agility and balance. It can run, jump, backflip, you name it. Then there's Sophia, developed by Hanson Robotics. Sophia is famous for her human-like appearance and her ability to hold conversations. She's even been granted citizenship by Saudi Arabia. These are just a couple of examples of the amazing robots being developed around the world. From healthcare to manufacturing to space exploration, humanoid robots are poised to play a larger role in our lives. The world of humanoid robotics is brimming with possibilities, and you, my software engineer friends, hold the keys to unlocking its full potential. Remember, robotics is a beautiful blend of software, hardware, and creativity. Your coding skills, combined with your imagination, can bring to life machines that can assist humans, explore new frontiers, and make our world a better place. So keep learning, keep exploring, and keep asking questions. The future of robotics is in your hands. From sensors to AI, robotics is a blend of software, design, and purpose. I hope this breakdown helped you understand the hidden complexity behind humanoid robotics. This is Latha Naidu creation, and I believe when we share insights like these, we don't just learn, we grow. Stay curious, stay inspired,